Hi, this is David at Seismic Rocks. Today I'd like to talk about Seismic Unix programming, calling the section Programming Part 1. I'll explain later why I call this Part 1. Well, let's try to find some source code. I have some aliases that I'll be using. Particularly, I have this SUSRC that goes to the main, and then there are a couple of graph, because the graphic programs that we typically use are split into different places. So let's go take a look at, so there are a bunch of directories here. Let's take a look at another way so we can see that these are directories by the D on the side here. What I want you to note here is, for example, let's look at noise. And these are source codes. They're all .c. And look at the statics directory. Again, C. What I'll be using for an example is in the amplitudes directory. And in particular, the one I'll be using today is the gain. An important part of doing programming is the Makefile. You've seen that in each of these directories there's a file called Makefile. And what I want to do is, first of all, make a copy of whatever it is I want to work with. So I'm going to make a copy of sugain. I'll call it sugain 2. And now to use this, that is to compile and link before trying to execute or run, to compile and link, I need to modify the Makefile. So I'm going to use that, my gedit editor on Makefile. And here's sugain. And what I want to tell you is that Makefiles are very delicate. So I'm very careful when I edit a Makefile. And what I did here is I just copied the row and pasted it. There are tabs and spaces that frankly make me very much afraid, because putting a space in the wrong place, putting a tab in the wrong place, it looks like it's a pretty simple file here. I use the space going over one, but you see this is a tab here. So it's two tabs in a space, which might not be important, but again, the Makefile is delicately built. If I was going to make a copy of SU0, my own version of SU0, I would not put it under the SU0, because this space here, I don't know what's going to happen. So I'm going to open this space, the line above, in this case, do a paste. And I'm going to key up and verify that this is a tab here. Okay, so this is a tab. So I'm going to come down here, and this is a tab here, and I'll put a here and 2, and I'll go ahead and save this. But I'm not going to keep it. What I'm just trying to show you here is that I'm very much afraid of all parts of a Makefile. So be very, very careful of your edits to make sure it continues with the same structure that other lines have. So I'm going to save that again after that edit. X out. So so here I have, there's my sugain 2 that I just created. And Now I want to go ahead and edit that. Now that I have my own copy of sugain, sugain2, I'm going to go ahead and remove some of the top lines here because they're now dishonest, because this is not the released version, but this is my own homebrew version. I don't want anybody to get the mistaken idea that this is an actual Seismic Unix product. But I do want to get credit for this in case I share this with someone. So that makes that official. Another place that needs documentation is down here in the credits section. So immediately below these two entries, I'll add a comment line about me. And I'll save that. That's the beginning to make my own section of this. Now, the way I'm going to use this for a demonstration, there's a John option here, which sets values for doing a particular kind of gain. So when the John value is not there, which is the same as a 0, then this particular gain is not done. I'll be setting John equal 1, which will be using these particular gain values. So I'm going to scroll down to where the John option is used. Here we go. If John is true, which will be a 1 in our case when running it, I'm going to use the warn function and just put a comment in here. So pretty simple. Remember the semicolon for our C code. I'll do a save here. And this is sugain2, so I want to find wherever sugain is mentioned here and correct this. Use the find. There are 4 occurrences, and looks like we've seen them all here. So that looks pretty clean. Again, we'll do a save. And we can leave this up. Let me go back to my edit that I made. There we go. Now, the way to use this is to run the make command. Again, in this directory, there's the Makefile, and we edited the Makefile. I edited the Makefile to put in the name of my program, and it's in the Amplitudes directory. All of these programs here in the Amplitudes directory have a set of libraries particular to these programs, and the Makefile knows which libraries are necessary to link with these programs. In each particular directory, let me open another terminal. Go up one again here. In each of these directories, the Makefile in each of these directories has the libraries specific to each of the programs, to this family of programs in any particular directory. So if I were to seriously modify a program for my own use, I need to start with a program that does nearly what I want to do because of, again, the libraries that are pertinent to that particular Makefile in that particular library. And that's why I call this part one of programming, because this discussion only pertains to modifying a program that will be using libraries that are in the same family as anything in a particular directory. If I needed to write a program that did stacking and, let's say, migration, then I would be crossing directories. I would be mixing directories. And to be honest, I don't know how to assure that a Makefile is going to have the libraries of mixing directories. So, getting back to work. The make command will use the Makefile in this directory. Let's see how it goes. Now you'll notice the messages here are only pertinent to the sugain2 program. That is, these sets of programs here that it ran through is just the sugain2 program. What I'm trying to say is it did not remake all of the programs in this directory. It recognized that only sugain2 was a new entry in this directory, so it only made the sugain2 program. As for the output, you have some warnings here, which bother me only a little bit, but it's a warning, not an error. And we have this successful message here that sugain2 was installed in my bin, my Seismic Unix bin directory, which means I can use it. So let's go ahead and pretend this is getting a self-dock on the sugain2, and let's see what we get. And this is what I did, sugain2. Okay, so that seems to work very nicely. The only thing left then is to go ahead and use the program. So let me go where I live, my home directory, and let's see what we have here. So there is a data set that I can use. So let's do that. That would be sugain2. And let's not use the John option at this point. Just put out a data set, call it johnno.su. And we have a johnno.su, and there are no messages to the terminal from that run. Let's change that now. And let's use the John option. Change that output to John yes. John equal 1. And we have a John yes. Let's make sure that's not a 0-byte file. And we have our output from the warn function. Right, so none of these are 0-byte. It ran successfully through the program. So it's really simple then, you see, to actually begin modifying a program of your own to do anything you want. And that's an application program. Now let's go ahead and turn our attention to a plot program. Let's work left to right here. Sorry, I'm going to use another one of my aliases. SUGrep. graph1 gets me to this directory. Let's see what's in here. There's 2 directories here. So here's xwigb. Over here, clear that. And here we have xwigb.c. And remember that suxwigb is the wrapper, wraps around program xwigb.c. Because I want to modify xwigb.c, let's close this. Because I want to modify xwigb.c, I have to modify suxwigb to call the wrapped program. So bottom line here is I have to make a copy of the wrapper program. Let's see what we have. Okay. Now do a copy here. Good. Okay. Now let's do an edit to suxwigb2 to call the wrapped program, because right now this doesn't know about the wrapped program. Because this is my own version, I'm going to go ahead and get rid of all this stuff. Do the usual. Okay, so now I want to find every place it says suxwigb. And it says there are 5 locations. Let's start with these 3. Let's scroll down, look for the other 2. That's 1, I'll leave that alone. And that must be the last one. Remember too that I'm modifying this for myself, so I will add a note here. And that's enough for now. Save. And while we're here, let's finish our work with suxwigb2. That would be finding where it calls xwigb. So let's do a check for that. It appears to be here. Let's do this. Do this. And we'll modify the command or the comment as well. Save. Close that, assume we're good. And remember that here in this directory there's a Makefile, so we have to modify the Makefile. Being extremely careful. Okay, that's probably pretty good. Save that, exit, and let's see if we can get some spaces here for our messages. Well, I see warnings here, but I don't see what I want to see, which is that this has been placed in my bin, in my path. So what I'm talking about is here. So I'll do an ls, CWP root. Well, I guess I have to here, xwigb2 is in my CWP root bin, so that's probably pretty good. Okay, so it has content, not a crash. Let's move on to then the wrapped program. Let's edit the Makefile. We have xwigb. xwigb2. Save. Exit. Now let's go ahead and make some kind of edit to xwigb2.c. Let me do that properly with the ampersand. Do our usual work. And scroll down a bit for the comments. And then we're looking good here. Do a save. And let's get back now to editing the name of this thing. Do do a search for xwigb. And it says there are 5 locations for this. I don't know why I jumped right down there, since there are 2 right here. And 2 more here. And we have our last one here. Let's save all that. Now let's go somewhere to make a comment. You might remember from an earlier video that I'm a fan of the Perk option. So I'm going to use this for my test space. Open here and add a comment, and I'm going to insert a comment using the warn function. I'm a big fan of making spaces. Get a printout of the Perk option here. Format the line. And semicolon for C programming. Let's go ahead and save that. Back over here, let's open a new terminal. And let me go home. Oops. Over here, I need to make the file. No one knows that I've made edits yet, so we already have the Makefile with edits, so it knows we have xwigb2. So I'll run make, and we have warnings but no errors, and we have the happy news that xwigb2 is in my CWP root bin directory. As I say, let me run this from home since it's universally available to me, since CWP root bin is part of my path. So the wrapper program that I have now is suxwigb2, and I have a small data set here supplying the Perk value, and let's say 97 for fun, and run this, and we have an output. And we also have my message with my Perk value. So suxwigb2 and xwigb2 are both working. Let me close the output here. And let's go back to xwigb2 and modify xwigb2, the wrapped program. Let's call this test 101. Keeping everything else the same, let's save this. And over here, as we ran make before, let's run make again because we have modified the xwigb2, the wrapped program. Again, warning, but we have success. xwigb2 is available in CWP root bin. So going back here to my personal home area, let's run this all over again, but this time use a new Perk value. Let's try this out. And we get an output, everything works, test 101. But the important thing that I wanted you to realize here, aside from how all this is working, there's a thought behind this. That is, I compiled and linked xwigb2 a second time because of the change I made to it. But I did not run make for the wrapper program, suxwigb2. nonetheless, even though I didn't run make on suxwigb2 after modifying xwigb2, suxwigb2 picked up the new version of xwigb2. So that means to me that if program A, or I'm sorry, let's say xwigb2, suxwigb2 depends on using xwigb2, I don't have to compile and link the wrapper program. I can make the modifications to the wrapped program all I like, as many times as I like, without having to remake the wrapper program. Alrighty, well, that's what I wanted to show you there. There's one other thought I have for discussion. Some IDEs, integrated development environments, they create a virtual environment. So I might say to myself, well, I want to work on xwigb2 now that I made a copy of it here, now that I made its new entry in Makefile. I'm going to go ahead and open an IDE here where it will create a virtual environment. Not every editor makes a virtual environment, but the most fancy ones do. I don't know how these things work. I don't know how the virtual environment works. But my thinking is that the virtual environment might interfere with the work of make and Makefile in this directory. I don't know, but I suspect it might. That is, if you make the changes here, and then if you make the edits to, let's say, xwigb2, and then you come to the command line and you run that make, then it might not work because of the interference of the virtual environment here. That is, the virtual environment is surrounding the file that you're editing, and so this directory here will not actually see, the make command won't actually see that edited file. I don't know, but it might be true. So my suggestion is that you create your virtual environment, that is, install and make that virtual environment for your IDE outside of that environment, but over here in your working environment. And then when you have your file ready to test, then you copy the file from your IDE into the working directory, the Seismic Unix working directory, and run the make there. That's just a thought. I don't know, but I just wanted to warn you in case you get stumped and you're inside your IDE and you're in this environment and you're trying to make and it's not working. This might be why it's not working. All right. Well, that's all I wanted to talk about today. And I thank you for coming by, and I'll see you next time.